And here we go. So next on the list is, what is it, fetch? Yes, fetch. So, main. List. Switch. Okay. All right. Okay. The fetch API. Integrated with the global window object, making it available on modern browsers. Excuse me. All right. All right. So we'll use this Pokemon. All right. So let's request my favorite Pokemon. Okay, we'll call it Haunter. And so try this response. If there's an error, say so. Await the response.json. And then fetch Pokemon. What is going on? Dude, wow. Alright. Oh, that's because it entered. There we go. Pokemon, huh? So what, that's it? Okay, well, let's see here. Okay, well, I'm looking at this and I know that I have to define this as a type in this function. And I'm seeing that what I started doing earlier, promise, in here is the name of the type. So, what's going on? Must return a value. Well, Hmm. So const data would want to be await response JSON as Pokemon. Is that right? Almost. Next ending return statement and return type does not include undefined. Return the data in the try block. Okay, so we gotta make sure we're throwing the error, returning the data as this type, and okay. All right. Well, actually, since I finished kind of early, this is a good time for me to show my progress on uh, the patient management system. It's like a appointment booking app I've been working on. Let's see. Let's uh, let's open up this VS Code. So I'll just do like a little intro to this one. It's using Next.js and online service called AppWrite, which has basically allowed me to uh, build the databases that are used to store the patient and doctor data. Let's see, I kind of show what's going on in here. Yeah, so we got different collections or databases, and for example, like here's one of the patients that I added, which is me, and these are no doctors yet, no appointments yet. Um, let's see. So you can add all the attributes. Uh, each line of patient data can be added as you normally would as a string or Boolean. Make certain things required. And let's see, is there anything else worth mentioning? So yeah, using Next, using this other service called ShadCN, which is a user interface library. And so far it's been pretty straightforward to work with, made with Tailwind, so also using that. Uh, so yeah, what happens here is this is the first page that you go to. Type in your name, email, and phone number, and it gets you here, which is where you would fill out more of a personal information, medical history, your identification, a scanned copy of it. For example, maybe it's in, yeah, I have a fake ID that I put in here for now. Uh, these are required, and where I'm at with this is you can submit this, and let's see, it'll take you to the new appointment page, but right now that's blank, and that's kind of what I'm building out now. But you can see that it'll take all the information from that form and save it as a new patient. So currently, yeah, it's pretty cool little user interface framework. Um, nice little date picker. I gotta fix this radio button. It's not filling in all the way. But let's just see what's up next. TypeScript promises. All right, we're going to go ahead and work through this one since we've got so much time left. I'd like to get at least an hour in on these exercises. Yeah. Okay. So let's get out of here. Let's open back this one. Okay. Let's see. Hmm. So let's cd into that. In JavaScript, promises are powerful constructs that make working with asynchronous operations more manageable and readable. They provide a way to schedule actions to be performed once the asynchronous task has been completed, either successfully fulfilled or with an error rejected. Please note that you will rarely find yourself in a situation where you will have to create a promise. However, you will frequently need to handle promises. This typically occurs when dealing with APIs or libraries that perform asynchronous operations, such as network requests, file operations, or any tasks that depend on timing or external data flow, where you do not have immediate access to the result. For instance, when interacting with third-party APIs, whether it's fetching data from a server, querying a database, or performing complex computations asynchronously, these APIs often use promises to handle the asynchronous nature of HTTP requests. By using promises, these operations do not block the main execution thread, allowing your application to remain responsive while waiting for data to load or an operation to complete. So the three states of a promise are pending. It's initial, neither resolved nor rejected. Fulfilled, promises have been resolved and the corresponding handlers will be called. And rejected, and the catch handlers will be invoked. Promises in JavaScript follow an event queue model where callback functions associated with asynchronous operations are placed into a queue when the operation completes. The JavaScript runtime environment has an event loop that continuously checks this queue and processes the callbacks in the order they arrive. This ensures that the code execution is non-blocking and that operations that take a longer time don't stall the execution of other scripts. So creating a simple promise. Okay. Takes a number of seconds and returns a promise that resolves to a string after waiting for the specified number of seconds. The return statement returns a promise of type string, providing resolve and reject functions to control its outcome. If seconds is less than or equal to 0, we check if the provided seconds are less than or equal to 0. If so, we immediately reject the promise with an error message. The set timeout delays the resolution of the promise by seconds, multiplied by 1,000, converting seconds to milliseconds, and then resolve the promise with a message. Wait for 3 invokes the wait for function, intended to wait for 3 seconds. The .then happens once the promise is fulfilled. After 3 seconds, we log the resolve message to the console. Catch error, console error. If the promise is rejected, we catch the error and log it to the console. This will output the error message without any additional error object metadata that might be included if you were to log the entire error object. Handling, fulfillment, and rejection of promises. Fulfillment handling. The fulfillment of a promise is managed by attaching a .then method to promise. The then method takes a callback function that will be called when the promise is resolved. Rejection handling. The rejection of a promise is managed by attaching a catch method, and that's used to define a callback that will be executed if the promise is rejected. Okay, excuse me. So we've seeded into the TypeScript promises exercise, and this is how the terminal prompt should look. Code solutions, name of exercise, name of exercise. Yeah. To run the code in this exercise, you'll be using the terminal to execute TypeScript files using the TypeScript executing program TSX. Okay. Okay. If you do not have it installed, you can install with install don't know if I do have it installed. I see here. Let's just try installing. Well, let's see if it's already installed. Alright. Examine the function definition in takeachance.ts. It takes a name and returns a promise object that will randomly fulfill or reject. Within main.ts, call take a chance and pass it your name. Add the following handlers to the promise object returned by take a chance. One that logs the winning success message. One that logs the error message. Hmm. Hmm. Yeah, so this is kind of what I want to put in there. Cool, it works. Now, what happens if I don't enter in a string? Oh, just puts in what's in there. It's often useful to develop a conceptual model of how things work, even if that model doesn't quite match reality. This conceptual model can help us think about the code and understand how it works without the need for a detailed, precise understanding of how things work. For promises, a good conceptual model is the event queue / event loop model. The JavaScript runtime system maintains an event queue of tasks that need to be executed. When the runtime is finished, all of its synchronous work, it looks at the event queue to see if there are any tasks to run. If so, it runs them. When those tasks run, they will do the following. Call a callback function indicating the task has been completed, or if it has not been completed, put another similar task back onto the event queue. When a promise is created, it's passed as a callback function that is the promise task, such as making a network call. The code then typically registers then handlers, catch handlers, and finally handlers by calling promise.then, promise.catch, and or promise.finally on the promise. When the promise task completes, the appropriate handlers are called. With this in mind, the event queue model of promises is as follows. When the promise is created, the promise task is synchronously put onto the event queue. The synchronous execution of the calling code continues until the end of the functions. When the current functions complete, the event loop runs. The promise task is taken from the event queue and executed. After the promise task completes, if it completes successfully, the promise calls the then handler. If it completes with error, the promise calls the catch handler. The promise then calls the finally handler in all cases. The first 20 minutes of Phil Roberts' JSConf presentation on the JavaScript event loop provides a good visual representation of the event queue/event model loop. Watch this after completing and submitting the exercise. For Git to work properly, your terminal needs to be within the root of the local repository. And we are, wait, this time it's time to return up one level. Okay. Okay. I think that's it. All right, so that is it for that exercise. I'm going to watch this outside of this video here. Just see what's up next. That one looks good. Okay. All right, until next time.